Welcome everybody to this video where we're going to talk about sequences as functions and defining a sequence recursively. So, a lot of new vocabulary here, so I'm going to try to break it all down and explain this as efficiently as possible, but as clearly as possible. So, first of all, talking about a sequence. So remember, a sequence is just a list of numbers that follows a certain pattern. And we have two types that we normally talk about. We have arithmetic, which is adding or subtracting to find the next number in the line, or in other words, we use the word common difference. The other word is geometric, which is where we multiply by something to find the next number in line. All right, so looking at this sequence here, we have negative 6, negative 4, negative 2, 0, 2. You can see that we are adding 2 to each term to find the next one. So this would be an arithmetic sequence. Since we have a common difference, we're adding 2 to find the next term. And when we define this recursively, we need 3 different parts. We need 1, 2, and 3. And we're going to define this sequence as a function. So if you remember when we worked with equations, we talked about f of x, where x was the input. Well, now we're going to use f of n, where n is the term number. Okay? So when we say the term number, looking at this list, this is our first term. This is our second term. This is our third term. This is our fourth term. This is our fifth term. And we could find more terms based on the rule that we are adding to find the next number in the sequence, or the next term in the sequence. So the first thing when we're defining recursively is we always have to define the first term. So we're going to use the notation f of 1, because this is saying f of 1, this is the first term, is equal to what? Well, it's given to us, and we know that it's negative 6. So that's the first part of our rule when we define this recursively. The second part is we actually have to define what this rule is. So in order to find the nth term, so the f of n, we need to take the previous term. So we're going to denote that as f of n minus 1. And what do we have to do with that previous term to find the next term? Well, we already determined we are adding 2 to the previous term to find the next term. So we're going to add 2. All right, so just to walk through as an example, if we were looking for f of 3, and we plug this in, so then f of 3, we need the previous term, so that would be 2, f of 2, plus 2. Well, up here, f of 2 is negative 4. And we're going to add to it 2, so we know f of 3 is negative 2. So I just kind of walked through that example just to kind of show you exactly how that definition works. So really all this definition is saying, or I should say this rule is saying here for number 2, is that we are taking the previous term and applying whatever common differences or the common ratio. In this case, we are adding 2, so we take the previous term and add 2 to find the current term we're looking for. And then the final thing we need to define is where does that term number start? Well, since we are given the first term, the next term defined in our sequence is 2. So n is going to start at greater than or equal to 2. Okay? So now, these are the 3 parts we have in order to define this sequence recursively. We first identified the first term. We identified what the rule is to find the next term when given the previous term. And then finally, we defined where n starts. And that's how you define a sequence recursively using function notation.